Okay, good morning, dear students. So today is 11th of May, okay, and today we will be discussing about, we will be doing new exercise, that is exercise 6.2. Okay, so in this exercise we will be learning the forms of infinity by infinity, infinity minus infinity, and 0 into infinity. Okay, so these three different forms we will be learning in this exercise. So first we'll see problems on infinity by infinity. Okay, so the first question is number 1, part 1. We're doing number 1, part 1. The question is limit x tend to 0. Now don't get confused with 0 plus, okay, and minus. It's just an indication. Plus means it's coming from the right hand side, and minus means it's coming from the left hand side. You just don't have to be confused with that. So whenever we check the limit, just put, even if it is 0 plus, just put x equals to 0. Okay, so wherever it is x, now we'll be putting 0. So sine 0 is 0, and log of 0 is infinity. Okay, and chord 0. Now chord 0 means opposite of tan 0. Tan 0 is 0. So tan 0 is 0, then chord 0 will always be infinity. 1 by 0 means infinity. Okay, so the form out here is infinity by infinity form. Now what we need to do, now the same thing that we have learned in 0 by 0 form, keep on differentiating the numerator and denominator by applying LH rule. So I'm pausing the video for here. Okay, so the form was infinity by infinity. So once I use LH rule, after using LH rule, differentiate the numerator and denominator. Differentiation 1 by sine into cos. Okay, cot is minus cos x square. So cos by sine is cot, and this is cos x square. This minus sign comes outside here, and therefore cot means cos by sine, cosec means 1 by sine, sine and square gets cancelled out, this sign goes up in the numerator, it becomes cos into sine. So when I now check the limit x tending to 0, just put x equals to 0. X equals to 0, cos 0 is 1, sine 0 is 0, so 0 into 1 is always equals to 0, minus 0 is 0. Okay, so don't get confused. Out here it was plus 0 to the 0 plus, okay, 0 to the power plus. Okay, it means the same thing. You just have to put x equals to 0. So all in all, it's the same thing. You just have to check the form whether it is by infinity by infinity. If it comes to 0 by 0, then you know what to do. And if you also get infinity by infinity, the same thing we have to repeat here also. Okay, so this was question number 1, part 1. Now I'll be giving some homeworks out here. Note down the homework. Okay, so next question I'm taking out here is question number 3, part 2. Okay, before that, your homeworks will be question number 1, part 2, question number 4, part 1, and question number 5, part 1. Please note down the homeworks, okay? And now we are doing question number 3, part 2. So in question number 3, part 2, we have limit x tending to 0, log tan 2x, base tan x. Okay, the base is not e out here. See, whenever we have a problem like this in logarithm, then we can always use the property log a base b as log a divided by log b. Okay, the same thing happens out here. So therefore we will be getting now limit x tending to 0, just remove 0 plus log tan 2x and divided by log tan x. Okay, log tan x. So therefore now we check the limit. Log tan 0 is 0 and log 0 is infinity. Tan 0 is 0 and log 0 is infinity. Okay, so the form out here is infinity by infinity form. Okay, and now I'm going to do differentiation and then show you the next steps. Okay, so far till here. So as we identify the form is infinity by infinity, so now I need to differentiate the numerator and the denominator by LH rule. So if I differentiate the numerator, I'll be getting 1 by tan 2x into sec squared 2x into 2, 1 by tan x into sec squared x. Okay, now in the next step, 1 by tan means cot, so cot 2x, 1 by tan means cot 2x into sec squared 2x means 1 by cos squared 2x into 2. Similarly, 1 by tan means cot x into sec squared x means 1 by cos squared x. Okay, so now cot means cos by sine, cot means cos by sine. So what happens out here is now I can cancel cos 2x and then square. I can also cancel cos and square. Okay, so let us see what we get now. So limit x tending to 0, then I'll be getting 2 divided by sine 2x into cos 2x. Okay, and whole divided by 1 by, sorry, this is not 2, this is only square. Okay, and this will be sine x into cos x. So now we can take the reciprocal. So limit x tending to 0, this goes up in the numerator, it will be 2 sine x into cos x divided by sine 2x into cos 2x. Okay, now I know this is well-known formula, sine 2x, but this can also be made in the formula if I multiply with 2 out here. Okay, so therefore multiplying with 2 and even multiplying with 2 out here. So therefore this gives us the next step as limit x tending to 0. I'm writing the formula. The formula is sine 2x, even this into 2 sine 2x divided by this is sine 4x, right? So therefore this 2 comes outside. The next step I'll be getting 2 limit x tending to 0 sine 2x divided by sine 4x. Okay, alright, here now after I get this 2 outside, I'll be getting 2 limit x tending to 0 sine 2x by sine 4x. Now even if I put the limit out here, limit x tending to 0, this is going to be 0 and this is also going to be 0. So the form is what? 0 by 0 form. Either I can do that or either I'll show you another step. Okay, so the form out here is first of all 0 by 0 form. So once by LH rule we get 2 limit x tending to 0, differentiation of sine x is cos, so cos 2x into 2 divided by this is cos 4x into 4. So 2 1s are 2 2s are 4, so 1 by 2 is a constant, it comes outside. So 2 is already here, 2 into 1 by 2 again